Here's example 2.16, kind of fun, I suppose. We're supposed to match linear functions to their graphs. So I'm given 4 linear functions right here and 4 graphs and asked kind of which is which. I like to do these by kind of looking for the oddballs. So when we're talking about linear functions, you're looking at 2 things. You're looking at the slope and the y-intercept. And of those 2 things, the y-intercept is easier to figure out. The y-intercept is just the height when you cross this y-axis. So it looks like 3 of these lines cross the y-axis up here at 3. But one of these lines, this one right here that's in, what is that, green maybe, crosses at -3. So kind of the oddball here is this guy that crosses at -3. This line, line 3, is the only one that has a y-intercept of -3. So in f of x equals mx plus b, the b is the y-intercept. So when I look over here, I should expect to see 3 different values that have +3 as b, and one equation, I guess, that has the value of -3 for b. And that one that has -3 for b will be this line in green right here, line 3. And that appears to happen here. So this one is 3. So now I got 3 more, and I look at these guys, and the way I'm going to distinguish them is based on their slope. So I got to look at this orange line, this blue line, and this purple maybe line. And which one of those are kind of the oddball? Well, in my mind, the purple one's the oddball, because the blue one's going up and the orange one's going up, but the purple one's going down. And by up and down, I mean when you read this graph from left to right. If you're standing over on this side and you're trying to get to this side, if you're walking along this line, you're going uphill. If you're walking along this line, you're going uphill. But if you're walking along this line, you're going downhill. The one that's different is this one, graph 4 here. By going down, I mean it has a negative slope. So exactly one of the 3 remaining lines should have a negative slope. So you stare at them and you're like, well, the slope is the m in y equals mx plus b. This one has a slope of 2. This one has a slope of 2. This one has a slope of -2. This one has a slope of 1/2. Here's the only one that has a negative slope. This guy right here must be 4. All right, now I got 2 left. If you're feeling brave, I guess you can just guess. You got 50-50 shot. But I'm going to go ahead and not do that. The difference between these two, well, they have the exact same y-intercept, but their slopes differ. One of them has a slope of 2. One of them has a slope of 1/2. So at this point, I'm just looking at this graph in blue and this graph in orange and trying to determine which one has a slope of 1/2 and which one has a slope of 2. Well, remember, the slope is the rise over run. So you start at any point you want. Let's look at the orange graph. Start at any point. Here's a point right here. Find another point on this graph. Here's another one right here. If I had to get from this point to this point, how would I do it? Well, I'd go up 2 and right 1. The slope is how much you go up divided by how much you go to the right. So it's 2 divided by 1. The slope of this orange line right here is 2. It's not 1/2, it's 2. This orange line, graph 1, corresponds to this top equation. And therefore, by process of elimination, this one's 2. When I'm using process of elimination, I like to check it out to make sure it works. So let's see if that works. 1/2 x plus 3. Well, let's see. This has a y-intercept of 3, so I start right here. And then from this point to create another point, I use the slope. And the slope is 1/2. So I want to go up by 1 and right by 2 to get a second point. If I connect this dot and this dot, I get this blue line here, which is graph 2, which is exactly what I put here. So it looks like that all works out.